Okay, so we got the problem. Seeing a lawyer costs us $200 for 30 minutes, $100 for 20 minutes. We put those points on a graph. 20, 100, 20 minutes, $100, 30 minutes, $200. And then we draw a straight line, the blue line. Ignore the white line for a moment. We want to get the equation of that line. We saw this last time, I think. We did the whole thing, where we know that the equation of the line is y equals mx plus b. M being the slope. So we pick up on that pretty quick. We calculate the slope. Take this point and this point. Our change in x goes from 20 to 30. That's a change of plus 10. Our y value goes from 100 to 200. That's a plus 100. Now, in my class, I call this a fundamental triangle. So if you're in my class, make sure you lock into that idea because I think it's important. But I'm not going to pose that on other people's classes. Okay. One way or another. And there's a formula. I like the picture way better than the formula because it makes more sense. But the formula just embodies the picture. You subtract x1 from x2, you subtract y1 from y2. You get the change in x, you get the change in y. That's all the formula is. And then you divide it. Okay, well, anyhow, so we get slope equals rise over run. That's 100 over 10, that's 10. And now our equation becomes y equals 10x plus b. If the equation is y equals 10x plus b, then that's everything we need to know except b. Because as soon as we've got numbers for m and b, we've got the equation, and we can do things with the equation. So y equals 10x plus b. To solve for b, we just take the coordinates of either point. It gives us an x and a y. Okay, we could use this point, but we should just arbitrarily use this one. So y is 100 if x is 20. So we can plug 100 in here and 20 in for x. And we can then solve for b. Okay. I'll make sure you plug 20 in for x. I think somebody plugged in 10. At least one person plugged in 10. I want to be careful about that. But anyhow, our equation becomes $100 equals 10 times 20 plus b. So we solve for b. Well, that's 100 equals 200 plus b. If we subtract 200 from both sides, the 200 here is going to go away. We're going to get b. A lot of times this is written out. You put a negative 200 here equals negative 200, which is just a true equation. Then 100 minus 200 gives you negative 100. 200 minus 200 is 0. And of course, 0 plus b is just b. B equals negative 100, which makes a certain amount of sense. Now my graph didn't go down as far as negative 100. So we don't quite get to the point where the line intersects the y-axis, but it's pretty clear that it'll intersect at about this much below the line, but at negative 100. So that's a pretty good approximation. Okay. Okay, so now we go from here to here, and then we go up. Our equation is then y equals 10x minus 100. And we ask for when x is time, at what time does y equal 0? Now we can estimate that in the graph. Then we can estimate the y-intercept. We talked about intercepts, graphing these things last time. So the y-intercept, what's it look like the y-intercept is here? Here's 8, here's 12, here's halfway between 8 and 12. So what is it? Can you show me some figures? Yep, that's 10, right? Okay. So that means what? If the time is 10, the cost is 0. Now, does that make sense? Okay, anyhow, so if we solve this equation, we get b equals negative 100. So y equals 10x minus 100. Y was 10x plus b when we found the slope. If we got the 10x. And when we found b, we got the minus 100. So when is y equals 0? Well, we can estimate from the graph. It looks like 10. And that's what people did. People held up 2 full hands. Said, yeah, if y is 0, x is 10. What's this mean? That means the first 10 minutes are free. You pay nothing until you get here, and then you pay $10 a minute. Okay? So I say first 10 minutes are free, and this may be hard to read, but then $10 per minute. This lawyer charges you $10 for $100 for the first 10 minutes, after 10 minutes, okay? And you can calculate the slope. That's pretty easy to calculate the slope. It's going to be $50 a minute because your change in x is going to be from 10 to 30. That's a change of 20. Okay, and you divide that 20 into 100. I don't know what I said for per minute. I think I said the wrong number, but it's $5 a minute. It's half as much. I think I said 50. Okay. Okay, well, you can calculate that. That's real easy. What does the y-intercept tell you? Well, you can estimate the y-intercept. What's that look like? And the camera just zoomed itself back. And from the fact that if you look at this line, the y-intercept looks like it's around 50 or 60, okay? Where you're sitting, you might not see my 50 mark, and my 50 mark might be a little low anyway. But if you wanted to estimate 50, that's all right. But maybe estimate 60. Now, that might not be accurate. Okay, so I kind of think 50 is right if you do the equation, okay? So the equation of this second line $100 for 10 minutes. $200 for 30 minutes. If you do the same thing we did, the slope is 5. It's $5 a minute. From here to here, your rise is $100. Your run is 20 minutes. Okay, $100 divided by 20 minutes is $5 per minute. And I think that B is actually 50. And 5x plus 50. Is that right? Does that fit the data? Well, if x is 10, 5x is 50, and you have 50, you get 100, which is exactly what you should get. And what if x is 30? Well, 5 times 30 is 150. And through $50 bills, 750, and you have no $50 bill, it's 200, and that matches this point. Now, a conclusion we can draw from this picture is this lawyer makes more money up to 30-minute visit. Okay, Now, if she decides to limit visits to 30 minutes, she's never going to make less money than this lawyer. Okay. For the 30 minutes. But as soon as you get past 30 minutes where these two lines intersect, and as we pointed out earlier, these two lines intersect. After this, this lawyer is making more money. He's making more money than she is. Okay. Now, if nobody wants to stay 30 minutes, this lawyer is going to be losing money, right? Compared to this fee structure. So the whole thing, how do you set up your fee structure? Your lawyer, you're going to make a lot of money anyway if you're able to get clients in at these prices. Okay. Of course, you got to maintain your office and your other business fees, but it's going to come out pretty good. If you keep your clients coming in all day, you're going to make a lot of money in a day. Unless you're this lawyer, nobody stays more than 10 minutes. Okay. Well, there you have it. And you could, apply this to many other situations, not just business situations. Okay. The whole idea of two lines, they intersect someplace, one line goes higher than the other at some point. So we draw conclusions, and I don't want to say too much more about that. We've got other things we want to talk about. Okay. Okay. So. A direct proportion y is a direct multiple of x, meaning that if x gets twice as big, this guarantees that y gets twice as big. If x is half as big, y is half as big. Okay, x is 10 times as big, y is going to be 10 times as big, as long as k doesn't change, and it doesn't. Okay, so that's our direct proportion. Inverse proportion. Y equals k divided by x. Okay. Now, if x gets bigger, your denominator gets bigger. You divide a bigger number into k, you're going to get a smaller number. Okay, well, that's pretty straightforward. So we start with those two ideas. Okay, so now when you use the word variation, it varies. If y varies directly with x, then, well, it's kind of skip writing it for time's sake, but that means y is in a direct proportion with x. Okay. Then we conclude y equals kx. Well, if y equals 50 when x equals 10, how do you put that information into this equation? Just write the equation for me. And don't take time right now. We got to keep moving. Don't take time to write out all my words. They're always there on the videos. And just skip to, you leave yourself room to write in if you have time, but just do what I ask. Just plug that information into the equation. And hopefully we're going to stay in focus. If y equals 50 when x equals 10, then the equation y equals kx becomes 50 equals K times 10. And how do we solve this? We divide both sides by 10. And that's the same as K over 1 times 10 over 10. 10 over 10 is 1. K over 1 is just K. So you end up with K. K equals 5. Now, we know that y equals 5x. Okay. So if x equals 30, what is y? So y is 5x. If y varies directly with x, and y is 50 when x equals 10, we solve for k and rewrite the proportion or the variation, whichever we want to call it. And we'll get to the variation in a minute. If y equals 5x. So now if we know another value of x, if x equals 30, we can find y. Okay. Now, if we establish the proportionality, we can find y values for a bunch of x values. Or we could find x values for y values. You know, if the equation was 100 equals 5x, you could solve for x, divide both sides by 5. Okay, so let's take this problem now. We're going to do an inverse proportion. Y varies inversely with x, and y equals 50 when x equals 10. What's y when x equals 30? See if you can follow the process. And you start with figuring out what equation you're going to write. Is it going to be this one or this one? Should be pretty obvious, but let's make sure. Okay, now in the interest of time, I'm going to go on with this. The biggest thing I can say, because almost everybody has written out something that shouldn't have been written out. Okay. Matter of fact, I can say everybody did. It was different things for different people, but trying to do too much in one step. The step is, first of all, you identify your equation. So let's we ID the right equation, which in this case is y equals k over x, right? Then plug in the given pair of values, the x, y values. And that gives you then $50 equals k over 10. And I don't think I saw anybody actually write this out without me telling them to. Okay. So that's a step that everybody's skipping. Well, it's easy to fix that, just stop skipping that step. Okay. So that's that's natural. Okay, you're trying to think ahead rather than thinking step by step. What did I do step by step here? I plugged in my numbers. First, I identified my equation. I plugged in my numbers. Then I solved the equation. Now, unfortunately, I can never anticipate what I'm going to run into when I look at what you're doing, okay? And I got to adapt what I'm doing here to what you're doing, so I'm not able to write this out as coherently as I'd like. I'd like to be able to write this, just all in one line, but this is in the way. So I'm gonna have to come up with it. I'm not blaming them in you, this is what you expect, okay? Usually class something unfamiliar is a little bit like herding cats, okay? You throw something out there, and sometimes everybody does everything right. Sometimes everybody comes up with creative ways to do it wrong. Mostly by skipping steps, okay? So yeah, that's, I was in a class, class at a level that challenges me. I come up with creative ways to miss things, okay? I'd probably be better at not skipping steps than most people are at this stage. But there are, I can't avoid being confused by something that's a little over my head, okay? Okay, well, anyhow, we solve for K. So let's rewrite, we got 50 equals K over 10. We don't want that 10 there. Now, we don't get rid of that 10 by adding 10. We don't get rid of that 10 by dividing by 10. We get rid of that 10 by multiplying both sides by 10. So we multiply by 10, meaning multiply both sides. I didn't have room to write in the words both sides, but that's understood when we're solving an equation. So we do 500 times 10 equals K over 10 times 10, okay? And then be sure we've got things lined up. By multiplying a fraction by a number, I strongly recommend that you remind yourself what's going on by writing that number as 10 over 1. Then you can see that, okay, I could rearrange this. Instead of 10 and 1 here, I could have 1 here and 10 here, and 10 over 10 is 1. And that gives me K. Now, notice when I'm talking about looking ahead and doing things before it's time to do them, I did that here. 50 times 10 is 500, so I had that 500 in my head, and I wrote an extra 0 here, right? And of course, I did that just so I could demonstrate that you and I can make a mistake. So you want to be careful. Because I knew I was going to be getting 500, but all of a sudden I saw 500 times 10, that'd be 5,000. Well, I knew that wasn't right. Okay, I was thinking too much. Instead of thinking step by step. Okay, anyhow, we get K equals 500. What's the next thing we do? After we get K, what do we do? What did I do on the first problem? And what do we then want to do on this problem? Because here are the steps we take so far. Write the equation, plug in, solve for K, get K. Now that we've got K, we plug K into our equation to get Y equals 500 over X. Okay. Now plug in the new value of X. Plug in the new X value, we get Y equals having the right kind of small here. Y equals 500 over, well, our new value of X is 30. Okay. And 500 over 30 is it's 50 over 3. It's not 166 2/3. It's 16 2/3. I'm having an epidemic of writing too many symbols. Okay. 16 2/3. Okay. Now, if we look back at our original information, what happened to X? X went from 10 to 30. It got 3 times as big, right? Well, if our denominator gets 3 times as big, the quotient's going to get 3 times smaller, or 1/3 as big. And 1/3 of 50 is 16 2/3. Okay. So X got 3 times as big, Y got 3 times as small. It went from 50 down to 16 2/3. Okay. Okay. So let's try. Okay, I'm not going to use the word jointly, but this will be a joint variation. I'm going to say Y varies directly with X squared. Directly with Z. And inversely with the square root of W. Okay. See if you write out an equation. It does that because we've seen what direct proportion means. We've seen what inverse proportion means. You're probably going to write something wrong. That's all right. We'll correct it. And if you don't write anything wrong, that's even better. So this equation here says Y equals Kx. Okay. Now Y varies directly with X squared. This is Y varies directly with X. What would change? Well, we would write Y equals Kx squared. Okay. That'd be Y varying directly with X squared. And also directly with Z. Well, if Y varies directly with Z, if it didn't vary with X squared and W squared of W, you'd write Y equals KZ, right? Now we've already got K here. Z would go in the numerator. Put Z in the numerator, okay? It's still direct, it's direct with Z. Okay. Then inversely with the square root of W. Well, that means inversely means you're going to divide. So ignore Z and W, Y varies directly with X squared, right? Ignore X and W, and Y varies, or Y becomes Z, Y varies directly with Z. Inversely, with the square root of W, inversely means when it goes in the denominator, Y equals K over the square root of W. Ignore X squared and Z. Okay. Well, now we can't ignore X squared and Z. We have to do something with it. So let's say y is 100, and x is 5, z is 8, and w equals 4. Now you can stop reading for a minute right here. Okay, I'm going to ask you something like, okay, tell me what y is if x is 10 and z is 2 and w is 64. Okay. I'm not sure I'm going to give you those numbers because I don't think I'm going to remember them. I think I've forgotten them already. But I can make up any set of x, y, and z numbers and ask you what y would be according to this proportion, right? But I'm not going to write that down yet. What do you know, if you're reading this problem, and then I say, okay, what is y if x equals this, y equals z equals this, and w equals this, okay? So that might be here. Ignore that. As soon as you get here, there's something you can do. Okay, because as soon as you get here, you got numbers you can plug into this. So plug your numbers into that. See what happens. Okay, so you know, a little bit short on time here, so let's move on through this. We've got y equals kx squared z over square root of w. And we focus on this. Okay. We stop here and write. We write this equation with the values we have for x, y, and w. And y, x, y, z, and w. Okay. And then we come over here and we see that that gives us 100. (25 times 8 over the square root of 4). (25 times 8 is 200. Square root of 4 is 2. Okay. So actually, I don't know your solution worked out there. But we get 200 over 2, and just coincidentally, that comes out 100. Okay. So we get 100 over 100 equals k times 100 over 100. And k equals 1. I got a little bit too fancy with those numbers. I didn't actually calculate them. I just knew they were going to give us an even numbers. We didn't have to worry about decimal. But I thought a little clearer. So we get there's our equation. We rewrite the equation with our value of k, which just happens to be 1. Okay. Then if I ask you what's the value of y when x equals 200 and z equals 24 and w equals 36. So again, we're kind of working up the board. We get y equals I'm gonna write the 1 there because you're gonna always write K. Although you don't really have to since it's 1. 1 times 20 squared times 2 over the square root of 36. And that's just numbers. 20 squared is 400. 2 gives us 800. Square root of 36 is 6. It's 800 over 6. Okay. Which is 133. So I did that quick in my head. Seems fairly obvious to you. So punch it in your calculator. You got 133.3333. Okay. So that's the process. It really just comes down to identify your equation. Plug in the values that you know. Solve for K. Take your equation and replace K by the number that you got. If you did here. And then take the additional information and do whatever it asks you to do.